Download this code from codegive.com, link in the description below. Troubleshooting Android rendering problems, a comprehensive guide. Android rendering problems can be frustrating. From unexpected UI behavior to performance bottlenecks, understanding the root cause and having the right tools is crucial for developing smooth and responsive Android applications. This tutorial provides a deep dive into common rendering issues, debugging techniques, and best practices to help you optimize your app's visual experience. Understanding the Android rendering pipeline. Before diving into specific problems, it's essential to understand the basic Android rendering pipeline. The pipeline describes how your XML layouts and code transform into pixels on the screen. A simplified view includes these key stages. 1. Layout inflation and view hierarchy creation *. The XML layout files are parsed and inflated into a tree-like structure called the view hierarchy. Each node in this tree represents a view, example text view, button, image view, linear layout. 2. Measure *. The view hierarchy is traversed to determine the size requirements of each view. The system calls measure on each view and its children. The measure method calculates the view's desired width and height based on its layout_width, layout_height, and content. 3. Layout *. After measuring, the view hierarchy is traversed again to determine the exact placement of each view within its parent. The layout method is called on each view and its children. This method sets the actual x and y coordinates and width and height of the view on the screen. 4. Drawing *. Finally, the view hierarchy is traversed once more, and each view draws itself onto the screen, or, more accurately, onto a canvas which then gets transferred to the screen. The draw method is called on each view and its children. This method uses the paint object, containing information about color, style, etc., to render the view's content. Important considerations *. Frame rate *. Android aims for a smooth 60 frames per second, FPS, meaning each frame must be rendered in 16 ms. Hardware acceleration *. Most modern Android devices use hardware acceleration, which leverages the GPU to perform rendering operations. This generally leads to better performance but can also introduce hardware-specific issues. *Layers Android uses layers to optimize rendering. A layer is an off-screen buffer that a view can draw into. Layers can be used for caching complex drawing operations or applying effects. 2. Common rendering problems and solutions. Here's a breakdown of common rendering problems, their causes, and how to address them. 1. Slow rendering / jank. Symptoms choppy animations, sluggish scrolling, delayed responses to user input. The UI feels generally unresponsive. Causes overdraw drawing the same pixel multiple times in the same frame. This wastes GPU processing power. Complex layouts deeply nested layouts or excessively complex custom views take longer to measure, layout, and draw. Long-running tasks on the UI thread performing network operations, database queries, or complex calculations on the UI thread, also known as the main thread, blocks rendering. Inefficient bitmap handling loading large bitmaps without proper scaling or caching can lead to memory issues and slow drawing. Excessive object allocation creating too many temporary objects during rendering can trigger garbage collection pauses, leading to jank. Custom views with poorly optimized on-draw. Custom views that perform inefficient drawing operations can significantly impact performance. Solutions. Profile with systrace, recommended systrace is a powerful tool that records kernel-level and application-level events. It provides a timeline view showing where your application is spending its time. Use systrace to identify bottlenecks in measure, layout, draw, or background thread activity. Asterisk how to use systrace asterisk. 1. Android Studio Tools Profile. 2. Select Profile System Calls or Trace System Calls, depending on your Android Studio version. 3. Choose the process of your app. 4. Start profiling. Interact with your app, triggering the problematic UI behavior. 5. Stop profiling. 6. Analyze the systrace report. Look for long blocks on the UI thread, excessive garbage collection, or GPU bottlenecks. Asterisk example systrace usage, shell command. Asterisk systrace categories asterisk. Asterisk GFX, graphics. Captures buffer queues, rendering operations. Asterisk view, view system. Measure, layout, draw. Asterisk WM, window manager. Window operations and management. Asterisk M, activity manager. Activity lifecycle events. Asterisk Dalvik, Dalvik VM, now art. Garbage collection, JIT compilation. Asterisk SCHED, CPU scheduling. Thread scheduling behavior. Asterisk frequency, CPU frequency. Shows the CPU frequency over time. Asterisk idle, CPU idle states. Shows when CPUs are idle. Asterisk disk, disk I/O. Asterisk app, application-specific events. You can add custom trace markers, see below. Asterisk eliminate overdraw asterisk. Asterisk developer options debug GPU overdraw asterisk enables a color-coded overlay that shows the amount of overdraw. Blue indicates 1x overdraw, green 2x, pink 3x, and red 4x or more. Ideally, you want to minimize the amount of pink and red on the screen. Asterisk techniques to reduce overdraw asterisk. Asterisk simplify layouts asterisk use constraint layout to create flexible layouts with fewer nested view groups. Flatten your view hierarchy. Asterisk remove unnecessary backgrounds asterisk if a parent view already has a background, don't set a background on its children if they are opaque and completely cover the parent. Asterisk clip drawing region asterisk use view.set clip to outline, true, to clip drawing operations to the view S-bounds. This is especially helpful for views with rounded corners or complex shapes. Asterisk remove invisible views asterisk use view.set visibility, view.gone, instead of view.set visibility, view.invisible, when a view is not needed. Gone completely removes the view from the layout process, while invisible still takes up space. Asterisk optimize layouts asterisk. Asterisk constraint layout asterisk use constraint layout for complex layouts. It offers a flatter view hierarchy compared to nested linear layout S or relative layout S, leading to improved performance. Asterisk include and view stub asterisk use include to reuse common layout elements. Use view stub to lazily inflate parts of the layout only when needed, example for error messages or ads. Asterisk measure spec optimization asterisk if you're creating custom view S, carefully consider the measure spec parameters passed to on measure. Avoid unnecessary remeasurement. Cache measured dimensions if possible. Asterisk tools layout validation asterisk Android Studio's layout validation tool can help identify potential layout performance issues and accessibility problems. Asterisk offload work from the UI thread asterisk. Asterisk async task asterisk use async task for short-lived background tasks. Asterisk however, be aware that async task has limitations regarding thread pooling and execution order. For more complex scenarios, consider using executor service or rxjava. Executor service use executor service for managing a thread pool for more complex background tasks. Handler thread create a dedicated background thread with a message queue using handler thread. Post messages to the handler to perform tasks on the background thread. *rxjava/Kotlin coroutines*. These libraries provide powerful tools for asynchronous programming and thread management. They can significantly simplify complex asynchronous operations. Work Manager *, recommended for background tasks that need to run even when the app is closed. Optimize bitmap handling *. Load appropriately sized bitmaps *. Use bitmap factory.options.in sample size to load a scaled down version of the bitmap. Calculate the appropriate in-sample size based on the size of the image view and the original bitmap dimensions. Use LRU cache for bitmap caching LRU cache is a memory cache that automatically evicts the least recently used bitmaps when the cache reaches its maximum size. This helps avoid reloading the same bitmaps repeatedly. Consider disk caching, example using a library like Glide or Picasso, for bitmaps that are not frequently accessed. Release bitmaps when no longer needed call bitmap.recycle, when a bitmap is no longer being used to free up memory. Note, recycle, can cause exceptions if the bitmap is still being used. It's generally better to rely on garbage collection, but understanding when bitmaps are released can help with memory management. Use WebP or PNG8 for images. WebP offers better compression than JPEG while maintaining similar image quality. PNG8 can be used for images with a limited color palette. Avoid excessive object allocation. Object pooling. Reuse existing objects instead of creating new ones, especially for objects that are frequently created and destroyed. Example paint objects. Use a pool to store and retrieve these objects. String builder. Use string builder instead of repeatedly concatenating strings using the plus operator. String concatenation creates new string objects each time, which can lead to excessive memory allocation. Avoid anonymous inner classes. Anonymous inner classes can create implicit references to the enclosing class, preventing the enclosing class from being garbage collected. Use static inner classes or separate classes instead. Optimize onDraw method, custom views. Avoid allocations in onDraw. Don't create new paint objects, path objects, or other objects within the onDraw method. Create these objects once and reuse them. Use canvas methods efficiently. Use the canvas methods that are most appropriate for the task. For example, drawRect is generally faster than drawPath for drawing rectangles. Clip drawing region. Use canvas.clipRect to limit drawing operations to the visible region of the view. Avoid complex calculations. Pre-calculate values outside of the onDraw method and store them as member variables. Use hardware acceleration wisely. If hardware acceleration is causing problems, try disabling it for specific views using setLayerType, view.layer_type_software, null. However, use this sparingly as it can significantly reduce performance. Use Trace API for custom tracing. The Android.os.trace class allows you to add custom trace markers to your code. These markers will appear in systrace, allowing you to pinpoint the exact location of performance bottlenecks within your application logic. 2. Incorrect layout/visual artifacts. Symptoms. UI elements are misaligned, overlapping, or missing. Text is cut off, images are distorted, or unexpected visual glitches occur. Asterisk causes asterisk. Asterisk incorrect layout parameters asterisk layout underscore width, layout underscore height, layout underscore margin, layout underscore gravity, and other layout parameters are not set correctly. Asterisk density specific issues asterisk layouts are not properly scaled for different screen densities, LP, MP, HP, HP, etc. Asterisk incorrect use of weight asterisk layout underscore weight is used improperly in linear layout S, causing elements to be sized or positioned incorrectly. Asterisk text size issues asterisk text sizes are specified in pixels, px, instead of scale-independent pixels, sp, leading to inconsistencies across devices. Asterisk custom views with errors in onMeasure, or onLayout, asterisk custom views are not properly measuring and laying out their children. Asterisk hardware acceleration issues asterisk hardware acceleration can sometimes introduce rendering artifacts, especially with complex custom drawing operations. Asterisk Z ordering problems asterisk views are overlapping in an unintended order. Asterisk solutions asterisk. Asterisk carefully review layout parameters asterisk double check all layout underscore width, layout underscore height, layout underscore margin, layout underscore gravity, and other layout parameters. Use the layout editor in Android Studio to visually inspect the layout. Asterisk use density independent units asterisk always use DP, density independent pixels, for layout sizes and margins. Use SP, scale-independent pixels, for text sizes. This ensures that UI elements scale appropriately on different devices. Asterisk use constraint layout constraints asterisk constraint layout provides powerful constraints that can precisely position and size UI elements relative to each other. Avoid using hard-coded pixel values. Asterisk avoid layout underscore weight. When possible layout underscore weight can be computationally expensive. If possible, use constraint layout constraints instead. If you must use layout underscore weight, be mindful of its impact on performance. Asterisk specify Android text size in SP asterisk. Asterisk debug on measure, and on layout, custom views carefully debug the on measure, and on layout, methods of your custom views. Ensure that they are correctly calculating the size and position of their children. Use the debugger or log.d statements to inspect the values of measure spec and the calculated dimensions. Asterisk experiment with hardware acceleration asterisk. Asterisk disable hardware acceleration for specific views asterisk if hardware acceleration is causing rendering artifacts, try disabling it for the affected views using setLayerType, view.layer_type_software, null. Asterisk disable hardware acceleration for the entire activity or application asterisk, use with caution. You can disable hardware acceleration in the Android manifest.xml file, but this can significantly reduce performance. Asterisk control Z ordering asterisk use view.setZ, or Android elevation in XML to control the Z ordering of views. Views with higher Z values will appear on top of views with lower Z values. 3. Memory leaks related to rendering. Asterisk symptoms asterisk the app's memory usage steadily increases over time, leading to out-of-memory error crashes. Asterisk causes asterisk. Asterisk holding references to drawable S or bitmap S asterisk keeping strong references to large drawable S or bitmap S after they are no longer needed can prevent them from being garbage collected. Asterisk context leaks asterisk holding references to activity or context objects beyond their life cycle can prevent them from being garbage collected, leading to memory leaks. Asterisk custom views with leaked resources asterisk custom views can leak resources if they don't properly release resources when they are detached from the window, example unregistering listeners or releasing bitmaps. Asterisk solutions asterisk. Asterisk release drawable S and bitmap S asterisk set drawable S and bitmap S to null when they are no longer needed. Call bitmap.recycle, to release the memory used by a bitmap, use with caution, as mentioned earlier. Asterisk avoid context leaks asterisk avoid holding references to activity or context objects for longer than necessary. Use application context instead of activity context when possible. If you must hold a reference to an activity context, make sure to clear the reference in the activity's own destroy method. Asterisk use weak references asterisk use weak reference to hold references to objects that you don't want to prevent from being garbage collected. The garbage collector can reclaim the memory occupied by the object even if there's a weak reference pointing to it. Check if the object is still valid before using the weak reference. Asterisk unregister listeners in undetached from window, asterisk if your custom view registers listeners, example broadcast receivers or sensor listeners, make sure to unregister them in the undetached from window method. This method is called when the view is removed from the window. Asterisk use leak canary asterisk leak canary is a powerful library that automatically detects and reports memory leaks in your application. It provides detailed information about the object that is leaking and the chain of references that is preventing it from being garbage collected. After adding leak canary to your project, it will automatically detect and report memory leaks. Check the logs or the Leak Canary app icon for leak reports. 3. Code examples and best practices. Here are some specific code examples demonstrating best practices for rendering performance. 1. Reducing overdraw with constraint layout asterisk asterisk. 2. Loading scaled bitmaps within sample size asterisk asterisk. 3. Using viewstub for lazy inflation asterisk asterisk. 4. Debugging tools and techniques. Asterisk Android Studio Layout Editor asterisk use the layout editor to visually inspect your layouts and ensure that elements are positioned correctly. Asterisk Hierarchy Viewer, deprecated but mentionable an older tool that allows you to inspect the view hierarchy at runtime. While it's been replaced by Layout Inspector, it may still be helpful for some situations. Asterisk Layout Inspector asterisk, Android Studio-Tools-Layout Inspector. A powerful tool to inspect the view hierarchy and the properties of individual views. It offers a more modern and interactive interface than the deprecated hierarchy viewer. Asterisk Developer Options Profile GPU Rendering asterisk enables a graph on the screen that shows the time it takes to render each frame. This can help you identify performance bottlenecks. Asterisk Developer Options Show GPU Overdraw asterisk, as discussed previously. Asterisk Android Studio Profiler asterisk, Android Studio View Tool Windows Profiler. The Android Studio Profiler provides detailed information about CPU usage, memory allocation, network activity, and energy consumption. Use it to identify performance bottlenecks and memory leaks. Asterisk Log Statements asterisk Strategic Log.d statements can help you track the execution flow of your code and identify the source of rendering problems. Asterisk Debugger asterisk use the debugger to step through your code and inspect the values of variables. This can be especially helpful for debugging custom views and complex layout logic. Conclusion. Android rendering optimization is an ongoing process. By understanding the Android rendering pipeline, using the right debugging tools, and following best practices, you can significantly improve the performance and responsiveness of your Android applications. Remember to profile your code regularly and address any performance bottlenecks as early as possible. Keep learning about new Android features and techniques, and always strive to create a smooth and enjoyable user experience. Good luck! Okay, let's dive deep into rendering problems in Android, exploring their causes, how to identify them, and, most importantly, how to fix them with code examples. This will be a comprehensive guide covering various aspects of rendering performance. Introduction, Understanding Android Rendering. Android rendering is the process of drawing your app's UI elements onto the screen. It's a complex series of steps that the Android system takes to transform your XML layouts, custom views, and drawing instructions into the pixels you see. Efficient rendering is crucial for a smooth and responsive user experience. Problems in rendering can lead to jank, stuttering or jerky animations and scrolling. Lag, noticeable delay when the app responds to user input. ANRs, application not responding. In severe cases, the app might freeze and become unresponsive. High CPU/battery usage. Inefficient rendering often consumes excessive resources, draining the battery. 2. The rendering pipeline. To understand rendering problems, it's essential to know the basic phases of the rendering pipeline. 1. CPU side, software. Measure and layout. The system determines the size and position of each view based on your layout constraints, view properties, like width, height, margin, and screen size. This involves traversing the view tree. Display lists. The system records the drawing instructions for each view in a display list. This list contains operations like drawing text, shapes, bitmaps, and applying transformations, scaling, rotation. 2. GPU side, hardware acceleration. Texture upload. Bitmaps and other image resources are uploaded from memory to the GPU as textures. Drawing commands. The GPU executes the drawing commands from the display lists. This involves vertex processing, geometry, rasterization, converting shapes into pixels, and fragment processing, applying colors, textures, and effects to pixels. Frame buffer. The rendered frame is stored in a frame buffer. Display. The contents of the frame buffer are sent to the display to be shown on the screen. 3. Common rendering problems and their causes. Let's examine the most frequent causes of rendering issues. 1. Overdraw. Cause drawing the same pixel multiple times in a single frame. This often happens when views are layered on top of each other, and the underlying views are fully obscured but still being drawn. Common in layouts with multiple background colors or images stacked. Impact. Wasted GPU cycles, increased processing time, and reduced battery life. Detection. Use the Debug GPU Overdraw developer option on your Android device. It highlights areas with different colors based on the number of times pixels are overdrawn: blue, 1x, green, 2x, pink, 3x, red, 4x+. 2. Layout complexity. Cause deeply nested view hierarchies and complex layout structures. The system has to traverse a large view tree to measure and lay out the views. Impact. Slow layout inflation and increased CPU usage during measurement and layout. It contributes to jank. Detection. Use Android Studio's layout inspector to analyze your view hierarchies. Look for excessively deep or wide trees. 3. Expensive calculations on the UI thread. Cause performing long-running operations, network requests, database queries, complex calculations, image processing, directly on the main UI thread. This blocks the UI thread, preventing it from handling rendering tasks. Asterisk impact asterisk jank, frozen UI and ANRs. Asterisk detection asterisk use Android Studio's profiler, particularly the CPU profiler, to identify methods that take a significant amount of time on the main thread. For frequent garbage collection, GC. Asterisk cause asterisk excessive object allocation and deal location, especially on the UI thread. The garbage collector pauses the application to reclaim memory, leading to jank. Asterisk impact asterisk stuttering and frame drops. Asterisk detection asterisk use the memory profiler in Android Studio to monitor memory allocation and GC events. 5-bit map loading and processing asterisk. Asterisk cause asterisk. Asterisk loading large bitmaps without proper scaling or decoding. Asterisk performing bitmap operations, resizing, cropping, applying filters, on the UI thread. Asterisk holding onto bitmap references longer than necessary. Asterisk impact asterisk out of memory errors, slow loading times, and jank. 6 custom view drawing performance asterisk. Asterisk cause asterisk inefficient drawing code in your custom views, such as asterisk creating new paint objects in OnDraw, expensive. Asterisk using unnecessary anti-aliasing. Asterisk performing complex calculations or allocations during drawing. Asterisk impact asterisk slow rendering and jank. 7 animations asterisk. Asterisk cause asterisk animations that are not hardware accelerated, too many simultaneous animations, or animations that modify expensive properties. Asterisk impact asterisk janky animations, CPU overuse. 4. Tools for identifying rendering problems. Android provides several powerful tools to help you identify and diagnose rendering issues. 1. Android Studio Profiler asterisk, CPU, memory, network. Asterisk CPU Profiler asterisk records method traces to identify performance bottlenecks on the CPU, including methods called on the UI thread. Allows you to see where time is being spent. Asterisk Memory Profiler asterisk monitors memory allocation, garbage collection, and memory leaks. Asterisk Network Profiler asterisk monitors network requests and responses to help identify network-related performance issues. 2. Systrace asterisk a command line tool that captures system-level traces of Android system processes, including the graphics pipeline, CPU usage, disk I/O, and kernel activity. Systrace helps identify bottlenecks in the rendering process that might not be visible through other profiling tools. 3. Debug GPU overdraw, developer option visualizes overdraw on the screen. 4. Layout Inspector, Android Studio allows you to examine the view hierarchy of your app and identify deeply nested layouts. 5. Hardware Accelerated Rendering, developer option enables/disables hardware acceleration globally. This can help you determine if a specific animation or view is not hardware accelerated. V solutions and code examples. Now, let's look at solutions and code examples for addressing each type of rendering problem. 1. Overdraw mitigation. Asterisk solution asterisk. Asterisk remove unnecessary background draws. Only set a background when it's actually needed. Asterisk use Android Clip Children and Android Clip to padding to prevent views from drawing outside their bounds. Asterisk use view.set visibility, view.gone, to completely remove views that are not visible. View.invisible still draws the view, just makes it transparent. Asterisk example asterisk. Asterisk solution asterisk use include and merge to reuse layouts efficiently and reduce overdraw. Asterisk example asterisk. 2. Layout optimization. Asterisk solution asterisk. Asterisk flatten the hierarchy asterisk use constraint layout to reduce nesting. Constraint layout can often achieve complex layouts with fewer views than traditional linear layout or relative layout. Use recycler view for lists. Recycler view is much more efficient than list view or grid view for displaying large data sets. Use view stub for infrequent views. View stub is a lightweight view that is not inflated until it is explicitly requested. This can improve initial layout inflation time. Example, constraint layout. Example, view stub. 3. Offloading work from the UI thread. Solution. Use async task, handler thread, executor service, coroutine, or intent service to perform long-running operations in the background. Use live data and view model for asynchronous data loading and updating the UI. Example, coroutine. 4. Memory management. Solution. Use weak reference for caching. Helps prevent memory leaks by allowing objects to be garbage collected when they are no longer strongly referenced. Release resources when no longer needed. Release bitmap objects and other large resources when they are no longer used. Use bitmap.recycle. Be cautious using recycle, since it can cause exceptions if used in multiple locations. Let the garbage collector handle it. Use it only when you are absolutely sure you are done with the bitmap. Use object pooling. Reuse objects instead of creating new ones repeatedly. Example, weak reference. 5. Bitmap optimization. Solution. Load bitmaps at the correct size. Use bitmap factory.options.in sample size to scale down large bitmaps before loading them into memory. Use RGB_8888 if transparency is required, otherwise use RGB_565. RGB_565 uses less memory. Use bitmap factory.decode resource or bitmap factory.decode stream instead of bitmap factory.decode file. These methods handle memory management more efficiently. Load bitmaps asynchronously. Use a background thread or coroutine to load bitmaps and update the UI when they are ready. Example. 6. Custom view optimization. Solution. Minimize object allocation in OnDraw. Create paint objects and other resources outside of OnDraw, and reuse them. Use hardware acceleration. Ensure that your custom view is hardware accelerated. Use canvas.savelir and canvas.restore to count carefully. These methods can be expensive. Avoid unnecessary anti-aliasing. Only enable anti-aliasing when necessary. Use path measure to optimize path drawing. Example. 7. Animation optimization. Solution. Use hardware accelerated animations. Most animations are hardware accelerated by default, but double check that Android hardware accelerated equals true is set in your Android manifest.xml file or on your views. Avoid animating expensive properties. Avoid animating properties that cause layout changes, example width, height, margin. Instead, animate properties that can be handled by the GPU, example alpha, translation x, translation y, scale x, scale y, rotation. Use view property animator for simple animations. View property animator is more efficient than object animator for simple animations. Use render thread. Execute complex custom animations off the UI thread. Example. 6. Best practices. Measure first, optimize later. Don't prematurely optimize your code. Identify the actual bottlenecks before making changes. Use the right tools. Use the Android Studio Profiler, Systrace, and other tools to identify performance problems. Keep it simple. Avoid unnecessary complexity in your layouts and code. Profile regularly. Regularly profile your app to identify performance regressions. Test on real devices. Emulators can be helpful, but test your app on real devices to get an accurate picture of performance. Understand the Android rendering pipeline. A good understanding of how Android renders UI elements is essential for optimizing performance. 7. Example, Systrace walkthrough. Let's illustrate a basic Systrace example. 1. Connect your Android device to your computer. 2. Open a terminal or command prompt. 3. Run the Systrace command *T10, record for 10 seconds. *omitrace.html, output file name. *gfxview sched frequency idle mwm app rest dalvik web view, categories of events to trace. Choose relevant categories for UI performance. 4. While Systrace is running, interact with your app. Perform the actions that you suspect are causing performance problems. 5. Open mitrace.html in your web browser. 6. Analyze the trace *. Look for long bars in the surface flinger and GPU rows. This indicates that the GPU is taking a long time to render frames. Examine the CPU section to see which threads are consuming the most CPU time. Look for the UI thread, render thread, and identify the methods that are taking the most time. Look for jank markers to pinpoint frames that are taking longer than 16 milliseconds to render. Use the Alerts tab to see potential issues detected by Systrace automatically. 8. Conclusion. Rendering problems are a common challenge in Android development, but with the right tools and techniques, you can effectively diagnose and fix them. By understanding the rendering pipeline, identifying performance bottlenecks, and applying optimization strategies, you can create smooth, responsive, and efficient Android applications. Remember to profile your app regularly and test on real devices to ensure the best possible user experience. Good luck.